Example number 2, construct the load diagram and find end reactions for beam B1 and girder G1. So now we're looking at beam B1 and then we will look at girder G1. We need the area load, we need the total dead load and live load on the flooring system that we have, which is provided here. Dead load includes a 4-inch thickness concrete slab with a density, this is density of concrete used, of 150 pound per cubic feet, PCF. 5/8-inch thick terrazzo, 13 pound per square foot per inch. Beam has a dead load of 31 PLF with a section of W8 by 31, and girder has a dead load of 22 PLF and the section is W1422. The live load is 40 PSF. So we need to start by calculating the total area load, which is dead load plus live load, and everything should be in the unit should be in pound per square foot. For concrete, we have a 4-inch thickness and the density is 150 pound per cubic feet. So we can multiply thickness by density and then we get pound per unit area. So dead load of a slab is density of concrete times thickness of a slab, which is 4 inches, and we divide by 12 to convert inch to feet, and that will give us 50 pound per square foot. That's the dead load of concrete slab. Dead load of terrazzo, 13 pound per square foot per inch times 5/8 inches gives us 8.125 PSF. So now we can add everything together. So our total dead load and live load is the weight of a slab, which is 50, plus terrazzo, which is 8,125. That's our total dead load, and our live load is 40 pound. So the total dead load and live load is 98,125 PSF. The load path in this example is from the floor to beam to girder to column. But we are only looking at beam B1 and girder G1. So we have the area load. If you're looking at beam B1, which are beams are the members supporting the flooring system. In order to calculate the load that we have on our beam W, so remember W is area load times tributary width of beam in this case. So first we need to find the tributary width for our beam. Beam B1 has two adjacent members, one on the right side, another one on the left side. So tributary width is half of the distance on the right side plus half of the distance on the left side, which gives us 2.5 feet plus 2.5 feet, which will give us 2.5 plus 2.5, a total of 5 feet. Again, we are looking at beam B1 here. It has two similar adjacent members, one on the right side, one on the left side. Tributary width is half of the distance between the adjacent members on each side. So the total area load is 98.125. Tributary width is 5 feet. We can calculate the load on beam B1. So if it's beam B1, W here is area load 98,125 pound per unit area times tributary width. But don't forget, we also have weight of beam by itself. So we also need to include or add dead load of beam, which is 31 PLF. So the total load that we have on beam B1 is, we can round it up and use 522 pounds. So we are still looking at beam B1. Here is beam B1. The span length is 24 feet. Here we have 24 feet. And from the previous slide, we calculated the load on the beam is equal to 522 PLF. Again, we have a simply supported beam, a symmetric system, so we can calculate the reactions as load times length divided by 2. Each reaction is equal to 6,264 pounds. So we calculated the load here as 522 PLF and the reactions. Each one 6,264. These are the loads transferred to the girder. So as you can see, beam is connected, beam B1 is connected to girders. And that's what we want to look at next. Now we want to look at girder G1. So we are looking at girder G1 here. And you can see that beam B1, B2, and B3 are connected on one side, and we have another set of beams connected to the girder on the other side. Pay attention that these two beams and here, these are connected to the column. So they don't transfer anything to the girder. The load goes to the column from the end beams. So we don't need to include them in our calculation. What we need to include is the reaction from these beams. So at these 3 points, we have 3-point loads, each one 6,264. So this is how much load is transferred from a beam connected to the girder. So at each one of these points, we have 60 to 64 pounds. And the same thing on the other side. So the total load transferred from both of these beams to the girders are equal to, so each one of these point loads are 60 to 64 pounds times 2. Again, because there is a beam on the left side and another one on the right side. That's why we multiply 60 to 64 pounds by 2. Okay? And this is equal to 12,528 pounds, or as shown in the figure, 12.5 kips. So that's the free body diagram for our girder. The total length here is 20 feet. So we have the length of 20 feet. Three-point loads pushing the beam downward. Then we also have dead load of girder by itself. So dead load of girder is 22 PLF. And then we have two reactions. We have, one more time, this is a symmetric system, so we can say that the reactions are equal to each other. The dead load, the resultant of this dead load is 22 PLF times total length, which is equal to 440 pounds. So now we have 3 loads pushing the girder downward. 440, 12.5, 12.5, and 12.5. We add all of these together. So we have 3 12.5 kips, or 12,528 pounds. These 3 plus weight of girder by itself. Then the two reactions are equal to each other. So you can divide that number and calculate each reaction. So the reactions in this case are equal to 3 loads, each one is 12,528 pounds. These are the 3-point loads, plus dead load of girder, which is 22 PLF times 20 feet, and this divided by 2. Each reaction is equal to 19,012 pounds.